My name is Muhammad Hamid Roslan, number matric DE100017, and I will be presenting the Map 4 project from Group 1. Each group was given an assignment to do, and we were given non-linear equation. Our group discussed the title of thermistor using the non-linear equation. This thermistor is a temperature measuring device. So the objective we conducting this project to ensure that thermistor calibrate is correct. To estimate the calibration thermistor, we just need to solve non-linear equation. The Steinhardt equation can be same after the calculation. After the secant method and the Newton-Raphson method are two non-linear equation that we study in chapter 1. The rate equation can be obtained using this method. Therefore, while using this method, the temperature can be properly determined by ensuring proper calibration. By resolving the problem, we can ensure the component used in the thermistor satisfy the most recent requirement in order for engineer to avoid make mistake when conducting electrical testing or creating electronic item. However, because of the fastest response time and highest sensitivity of this small device, we will have to deal with calibration and testing issue. The idea is to find the range of the resistance is the within acceptable limit at 19 Celsius. Thermistor are temperature measuring device that work on concept that temperature change. The thermistor material change the electrical resistance. The temperature may be determined by measuring the resistance of the thermistor material.
Hi, Assalamualaikum. My name is Rodania Ibisha binti Rosli, method number CE190224. So in this part, I will present about the method. The method that we have learned is non-linear equation, which is the bisection method, secant method, and Newton-Raphson method. What is the suitable method to solve the problem is we will apply secant and Newton-Raphson method to solve the case issue in electrical and electronic engineering that involve an unknown thermistor resistance and temperature. The value of the roots of the above equation were determined using both approach. According to the data that we utilize, which is resistance and temperature declines, an example negative temperature coefficient thermistor will be provided. As a result, we may conclude that resistance and temperature are proportional. So how to solve it? The second method, we need to simplify the equation provided. Second, we need to find the root of the equation. The roots must be different sign and less than 0. Third, we need to make a table for iteration by using this formula, which is x equals to a multiplied with d minus the b multiplied with c divided d minus with c. And fourth, we need to calculate the absolute relative approximate error for each iteration. This shows the manual calculation by secant method. The formula below shows the relationship between the temperature and resistance of the thermistor. First, we need to simplify the equation. For the step 2, we need to find the suitable roots using above equation using the equation in step 1, which is the value of R. We assume 11,000 and 14,000, and we substitute it in the equation in the step 1, and we will get the value. And for the step 3, we need to build the secant table, which is the value of R for iteration 0 and 1. We get it from the value that we assume of R, and FR, we get it from the equation after we substitute the value of R into the equation of FR. For the iteration 2, we get it from the formula, which is A multiplied with D minus B multiplied with C divided by D minus with C. For the step 4, we need to calculate the absolute relative approximate error for each iteration, which is iteration 1, iteration 2, iteration 3, and iteration 4. This shows the step for Newton-Raphson method. First, we need to simplify the equation of the problem. Second, we need to differentiate the equation. Third, we need to make a table for iteration for formula, which is in part for iteration 1 is A multiplied, which is the part in R, which is A minus with B divided by C. And fourth, we need to calculate the absolute relative approximate error for each iteration. It shows the manual calculation for Newton-Raphson method. For the step 1, we need to simplify the equation, and for the step 2, we need to differentiate the equation of FR. For the step 3, we need to build the Newton-Raphson table. And for the step 4, we need to calculate the absolute relative approximate error for each iteration, which is until the iteration 2, as stated in Newton-Raphson table. And how to analyze and discuss the method based on the instruction provided in the project. We need to solve a mathematical problem in any field by referring to our topic. Using two different methods, we analyze and discuss among group members before deciding on an issue which chapter to apply. In addition, we will apply two alternative ways to address the problem. We choose an issue relevant to our course, which is electric and electronic engineering. In addition, we choose chapter 1, which is nonlinear equation, and finally we decide to address the problem using the secant method and the Newton-Raphson method. After that, we analyze the result by finding the absolute relative approximate error for each iteration. The formula was used on both method, which is secant and Newton-Raphson method. Besides that, we compare the iteration that we use in secant method and Newton-Raphson method. In secant and Newton-Raphson, the absolute relative approximate error for the last iteration is 0.02% and 0.24% respectively. Aside from that, because of the trimester fundamentals, the higher the sensitivity, the better the accuracy of the findings.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahimi bin Muhammad Freddy. My metric number is DE190153. So my task is to explain about the result and finding for our project which is using secant and Newton-Raphson method. So what are our result? We obtained two outcomes, which is from manual calculation and software simulation. And the simulation that we use is Excel. Because it uses basic formula to add, divide, multiply, and subtract two or more derivative values. It also can utilize the AutoSum function to simply sum a sequence of numbers. It also duplicates a formula into neighboring cells to eliminate the repeat process for solving mathematical problems. So there is the comparison of second method for manual calculation and software simulation. So for both calculation and simulation, we get the iteration is 4, and the value for FR is quite same. Next is the comparison of Newton-Raphson method for manual calculation and software simulation. So both of them have the same iteration, which is 2, and the value also quite same for both manual and calculation and software simulation. So from the result, the equivalent of R is 13078.4 obtained for both method but different number of iteration. We demonstrate answer by calculating the percentage of absolute error for each iteration and simulating the result in Excel. So this is the formula, and this is the answer for the absolute relative approximate error for last iteration. Next is the for Newton-Raphson method. This is the calculation of iteration for last iteration. So the approximate, the value of R is 13078.37193. So from that, we can obtain value of for R4 for second method and R2 for Newton-Raphson method. The value of R for second method is much bigger than the value of R for Newton-Raphson method. And we also find that Newton-Raphson method is more accurate. Then uses of software simulation to prove the manual calculation. So the result is the output number and iteration are almost same for both manual and software simulation. So what are our findings? We determine the relationship between the thermistor resistance and temperature on the real resistor. The equation depicts the connection between the thermistor resistance and temperature had been simplified. The outcome from the relationship is the Steinhardt equation, this is the equation. So to obtain the roots, first we need to determine the value for resistance at 18.99 degrees Celsius, and we get the value for resistance is 13072.73 ohm. So why we get the result? Because we need to identify the iteration to estimate the root of specific equation, and find the iteration give R0 13078.4 ohm. So based on the result from the manual calculation, the value of resistance is acceptable among the others. The absolute error in the last iteration for the Newton-Raphson method and second method is 0.23% and 0.02%. So it meets the criterion, which is the absolute approximation error is less than 5%. So we discover that Newton-Raphson give the simplest technique to determine the value of resistance. So the last one is Why we get this finding? Because in general, the acquired value of resistance is confirmed by setting the temperature. Other than that, we know the resistance value we acquired is legitimate and valid. The table in manual calculation and software simulation shows the data iteration 4 and 2 same in the Newton Raphson method. And the last one is after we get the same value, calculation be ended because we achieve the desired number, which is 5% of F13102.73 equal to 5.597 to the power of -7.
So the conclusion, after applying Newton Raphson method, we discover that it could provide us with reliable data. This is because the method do not give less error than this method. Finally, we understand the bisection, secant, and Newton Raphson technique is helped by this method. This method can identify which provide advantage and disadvantage. Thank you.